Hi everyone. Waste management is the main topic to be considered by whole world in this current situation. So in the waste management, mainly we consider about the 4R concept. That means reduce, reuse, recycle and replace. Today our discussion is headed on recycling process. That means safe recyclers and innovation for recycling of post-consumer packaging waste multi-layer packaging. So I cordially invite to conduct our session to Mr. P.B. Raman, a consultant in rubber and plastic sector, recycling sector. Sir, this is the time to you to conduct this session.
Thank you for the introduction. I have a series of charts to present outlining the topic of today, and I wish to know whether there will be questions on each chart or we keep the question towards the end of the session.
We will keep the end of the session, sir.
At the end of the session. Okay. Shall we go ahead?
Yes, sir. This is time to you, sir.
Yes. You have aptly put that the waste management is very crucial in plastics business, in plastic industry and plastic materials, because of the problems that we see globally in dealing with plastic waste. And we at Steer have developed certain solutions dealing with unrecyclable waste. Because in India, a lot of recycling takes place because of the low-cost labor availability in the form of rag pickers in cities who go and pick up all discarded plastics and salvage and give it to reprocessors who make granules for remolding other items. So that is in a nutshell what is happening. In the process, there are certain unrecyclable streams which the rag pickers cannot, do not even pick it up because they know there's no money in it. So they are left unattended in the municipal waste. Much of it lands up in landfills, or they get polluted in the drainage and sewerage and all that, create all kinds of problems. So we have decided to tackle that issue by developing certain machinery and process to recycle unrecyclable plastics such as multi-layer film, co-extruded multi-layer film, or heat and pressure laminated composites or adhesive laminated materials, which are more than one polymer, sometimes as many as 7 polymers or 5 polymers with the tie bond and all those things. And also lamitubes, which are very common. In Sri Lanka, I'm sure you use lamitube for toothpaste or cosmetics, creams and whatnot, and even certain medicinal items. So they also are not able to reprocess because lamitube typically have an aluminum layer and a plastic layer, and they don't know how to segregate. And some of them salvage aluminum out of it, but leave the rest discarded. So that's in a nutshell the problem of waste plastics. And I'll go about to explain what we do to pick up those waste plastics. We have 2 types of machinery to deal with this situation. So I'll start my presentation now. The company promoted by Steer, you will very soon hear about Geomatter. That will be the company that is going to handle. Right now it's handled by Steer, but eventually it will be handled by a company called Geomatter. And we also have a product called Plumber. Plumber means recycled plastic lumber. So what we do is we pick up these waste plastics and convert them into a lumber, typically like a wood, timber kind of product. which you can work like wood. So it does two purposes. One, it clears the waste plastics from going into landfill or polluting the municipal sewerage and drainage and other things. It is reborn as a wood substitute, which is superior for certain application like outdoor furniture, because wood doesn't last long. Metal also doesn't last long in outdoor furniture because of corrosion, or wood gets it rots after some time. So we have an elegant solution not only to clear the environment of waste plastics, but give them life as a wood replacement. So that's in a nutshell what I'm going to describe. Next chart, please. This chart tells about what we do globally. The material recovery through refinement in Europe and other places. Typically, you have this monomer to polymer to plastic, and use of plastics, single use or multi-use of plastics, and finally they get discarded. Most of the plastic that appear with a short life are the single-use plastics. When I say single-use, I am sure you all will be able to understand. Packaging items, where you go to the market and buy items in a plastic wrap, plastic container, or a plastic form-filled pouch. And after emptying the product for consumption, you throw it away. So they are single-use, and even the food containers that you get from Swiggy or Zomato coming to your home is in kind of plastic containers. They are also single-use. Some people may reuse it, washing it, but they are short-lived products again. So these products end up very fast in the waste stream. And as I said, monoplastics are readily converted. PET bottles are fully converted in India because people make fiber out of it, coarse fiber for upholstery, or even t-shirts, So that is entirely consumed, and the rack pickers are also happy picking it up because they get money out of it. But if it's a laminate which is lying around, the rack picker doesn't make 5 paisa also out of it. So he doesn't pick it up. They are left unattended. So are the, flimsy disposable cups and containers. You go to the picnic spot or a bar or a public place, after drinking beverages, people just throw them out. Some people it is thrown into the bin, no doubt, in most places, because the bin concept has come to India in a very big way. But then from the bin, people who take it, if they find it useful to convert, they convert. Otherwise, they left discarded. There is a segregation taking place. The plastic that cannot be recycled are left unattended. Next. This shows the enormity of the problem. What we see today is going to get worse in times to come. That's what it is. If you look at the global estimate for a calendar year 2030, something like 385 million metric tons of plastic waste generated. Correct? And it went up from calendar year 2019 from 257 to 385 is a projection. And India is no different if you look at it. In the financial year 2020, we had 4.2 million metric tons of waste plastics, and it's projected to go to 8 million metric tons by 2030. So there'll be a substantial increase in the untreated plastic waste, 1.5 times to 2 times in India from what it is today. So we are talking about an intelligent way to handle this waste from first mile to last mile. That is from the source of its waste plastic generation to useful products going back to the consumer with reduced greenhouse gases emission. And that's the objective of this whole development. It talks about eliminating plastic waste from reaching our oceans and water bodies and landfills and municipal trees waste, prevent pathogens from entering the environment. This is important because after the COVIDs, we are all limping back to normal. And you know how so much of medical single-use products are getting wasted, dumped, mask or protective equipment made out of polypropylene non-woven fabric, other things like gloves, tubings, IV solution bottles, pouches, so on and so forth. They are all single-use products and they get discarded by hospitals. And there is a worry of pathogen because these products still have toxicity as well as virus and germs. So, what do you do to kill those things? We have a machine that will give a product free of pathogens. I'll come to that. And convert commingled plastic waste to sterile and densified plastic chips. What it does is the safe, what do you call the recycler is a very compact machine that operates on domestic power supply, 220, 240 volts. It is noiseless. It's supposed to be handled even at home. Ideal for a cluster of apartments where there is a sizable collection of waste plastics from an cluster of 50 apartments or 100 apartments. And it eliminates the need to transport bulky waste plastics because waste plastics are bulky. They're either blow molded or injector molded containers or film, which are bulky. Okay, plastics are very light. Most plastics are one or below one density. So you have to compact them. So the machine does it by processing any item that you throw into it into a chip by melting and converting it into a chip. Once you have a chip, its compact form, like a granule, plastic granule, you can handle it. You can move it to another site to a bigger machine that can take it from here and convert it into lumber. That is the concept that we are talking about. Jumped. So this chart is talking about the intelligent compounding at the heart of manufacturing of whether it's a pharmaceutical product or a plastic or a food or a biomaterials. Much needed emerging technology by regulators is intelligent compounding. Compared to other technology, our intelligent compounding engine has increased capability by 100 times in sophistication during 30-year journey to reach this critical stage of deployment. We are talking about a co-rotating twin screw extruder system, which can be employed not only in compounding of plastics, but also in inline processing of recycled plastics with other ingredients and extrude continuous lumber or a cross section or a profile, as you call it, out of it from waste plastics. So we are talking about two machines, one that will compact the plastic at its origin, at where it is generated, the waste plastics, and sending it to a bigger machine that will convert the waste plastics into a lumber. So Steer has led this development intelligent compounding with 25 important inventions that have protected something like 150 patent applications around the globe. So these inventions are, in a nutshell, the technology of processing of plastics, waste plastics into useful value-added products like lumber, the addition of various ingredients to fortify the waste plastic into a stiff wood-like section. So there it is covered by certain innovations and inventions. Now we come to the machine that compacts the waste plastics. We call it safe recycler. It's a miniature machine. You can scale it up. The machine that we are showing is 10 kilo per hour and consumes only half a unit per kilo of converted plastics. Noiseless. And what you put and what you take out is totally pathogen free because the material undergoes very sterile heating cycle where none of the bacteria or viruses will survive. So that's a chip you get out of it or the granule you get out of it is pathogen free. That's in a nutshell the feature of this machine. You compare this machine with other existing recycling machine, like you have different makes we have compared with, and you see that the safe recycler ticks on all the points. From operating in domestic level, mobility of the machine, automation of the machine, sterile and densified output. I talked about it. No sorting required. What you dump is all mixed plastics. You don't have to sort it. You don't have to segregate it. Energy efficient, half a unit per kilo output, and it's processed at source. Where the waste plastics are generated, it can be put there and converted into a compact form. So that is the feature of this machine. It just gives you an idea of the enormity of the potential of this machine, particularly in India. So the chart describes about so many hospitals that would need this machine, commercial places like airports, railway stations, public eateries, so on and so forth, large office buildings. They have their own cafeteria and catering. Then residential, mostly urban. We are talking about urban, where the consumption of plastics, I would like to mention at this stage, the urban population in India consumes as much plastics as Western population. If you look at overall, India may be consuming only 12 to 13 kilo per person per capita, whereas the global average is something like 80, and advanced countries like USA, Europe is 100 kilo per capita. But really, at the urban level, we consume as much plastic as others. The problem of the generation of waste plastic is therefore as much as it is seen in other countries, in urban areas. We fortify the waste plastic because if you look at the waste plastics, most of it is packaging materials. They are flimsy, flexible pouches and films and laminates that do not have the stiffness. They are not originally designed for stiffness. They are designed to protect the product, whether it's a food item or any other item. They are to guarantee a shelf life in the shop. So you need to stiffen this plastic to convert it into a wood substitute like a lumber. We do it with minerals, right from calcium carbonate to clay to the natural fibers like jute and hay. We have experimented, and then long fiber like glass. We use glass rovings, not chopped glass, to reinforce the product to add stiffness that is needed for the final use. We go through a system of compatibilizer, coupling agents, and antioxidants to get profiles. What I have shown here are sections, sheets, rods, door frame profiles, and lumber sections in 25 or 25, 75, rectangular and square sections, solid sections. You'll find that we are also using growing agents to get a porosity of the material to make it lighter. This is the R&D plant that we operate. We will scale it up very soon when the geometry company is formed. This is basically an extruder. We start with the extruder and put the material in the hopper and take out a product, which is extruded. It goes through a system of water bath and vacuum section. Yes. Anybody asking for any question? Should I go ahead? So it goes through a step, which is the takeoff equipment for any extrusion product, water bath, vacuum section, and haul off equipment like Caterpillar and cutting. You have to cut a long extrusion section to 4 to 5 meters so that can be handled in a truck when you send it out. So that's a picture of that extruder that you see, extruder line as you go. Yeah. Now these are different products that we have developed so far. We have solid panels, we have the wall panel, which we extensively use for cladding, balcony wall claddings where wood cannot be used for reasons known to you. Door frame. Door frame is a very interesting product. It's picking up very fast in India because wood is scarce and good wood is not available. Teak wood is very expensive nowadays. So, and people have realized that the wood gets eaten away at the floor when we use aggressive chemicals after the COVID and all. People use very aggressive chemicals to mop and clean the floor, and they corrode the lower end of the door frame. So people have preferred to go for synthetics, and first to use was sawdust filled PVC profile. What do you call that?
WPVC.
Yeah, W.
PVC.
No, not WPVC. Anyway, not WPVC. So we have found with the recycled plastic, we are able to develop a door frame which is half the cost because PVC is an expensive material. And so we have been able to achieve this, and we see a good acceptability on commercial angle for this product. Then, as I mentioned, the lumber, which in different sections. Actually, when you start working with wood, you need to shave to a particular design and a size of lumber. We pre-plan the size of the lumber in the extrusion, so there's no waste. If you go to a typical wooden furniture or woodwork station, you will have a lot of shavings, sawdust and wood shavings. You don't find them here in this product. That's another advantage of wood. Next. Hollow profiles are possible with electronic e-waste, we call them. Most of the e-waste is styrenics. The cell phone that you throw after 2 to 3 years, the 3-in-1 photocopier, printer, 3-year life, the old monitors, which had a cathode ray oscilloscope behind. Nowadays, all plasma and LED and LCD sleek monitors, they still have plastics. The frames are plastics. So they all come back. They all come back for, destruction. And people salvage, they remove the motherboard, they remove connectors, contactors, and just offer the moldings. And moldings are crushed in a mill, and we use that. And it's available in plenty nowadays. The e-waste generation is very high. Whether it's a keyboard or a monitor or a cell phone or whatever, their life is short, not more than 5 to 10 years. So they keep coming to the market. You'll see a lot of product that we have developed out of the lumber. Ideally, these products are very good for outdoor, for a garden furniture or a park bench, because nothing happens to these items. Wood will not last long. If you can, there are ways in which you can even add more value to it by painting it and even, you know, have it at home inside your house. Dimensionally very accurate. And pallet is a very huge opportunity for this lumber because globally wooden pallets are used and people are wanting to stay out of wood. So that's another huge application we have. Uh, so we can go on with more items. Yeah, these are items that we have developed. We jointly work with the National Institute of Design, who give us inputs on ergonomics, how to design a chair for comfort and all those things. So we incorporated some of those features in our furniture. Now we don't make furniture. We have shown the possibility of making this furniture for people to buy our lumber and start a business. Because to start a business, you don't need any much investment. You need space, and you need basic equipment to which you are familiar with woodworking, saws and chisels and those kind of things. Material recovery through direct relay interesting compounding has the following merits. Um, Long fiber reinforcement I mentioned about to stiffen the lumber, control over density by foaming. You can use azodicarbonamide or other foaming agents to reduce the weight of the product. High quality devolatilization because our extruder can handle that. It has a vacuum section which devolatilizes all the unwanted odors and vapors that's coming out of recycled plastics. Coupled to render the material inert, we use coupling agents, as I mentioned, thoroughly homogenize and compatibilize to enhance the part because that's the function of the extruder. An extruder is supposed to homogenize the melt with all the ingredients and recipes that we put in so that every ounce of it when it comes out is consistent. So in the case of recycled plastic, also different plastics melt at different temperatures, but when it exits the extruder, it's a homogeneous melt. So that is the wonder of this machine. Again, very energy efficient, 0.5 kilowatt hour per kilogram of output. And you can make the machine to be 100% inline testing with the flexural modulus of the product. So you can test the flexural modulus, and if you find that the modulus is not adequate, you go back to your recipe and siphon the product with the suitable ingredients. So in conclusion, the problem of co-mingled and contaminated plastic waste material entering our landfills and oceans from around the world can be avoided with this system. Post-COVID, urgently for safe solution of pathogen-free recycling in hospitals and communities. So the solution you have seen, convert mixed, co-mingled, multi-layer contaminated plastic waste into valuable structural products, leveraging the safe recycler, which converts unsorted, not cleaned, mixed plastic waste streams consisting of various flexible materials, polypropylene, polyethylene, polyester, polyurethane, nylons, and rubbers, and so on. I give an example of a mask, simple mask, the COVID mask, we call it. It's made of three materials. One is the non-woven polypropylene fabric. Second is the elastomer, the elastic band that we use to wear it. And third is a small steel rib that gives a contour on the nose. So there are three materials, and this machine will handle all the three and crush it. You'll have trace of metal in it, certainly, but it's immaterial for a lumber application. That's in a nutshell my presentation. Question time? Hope you could follow through the presentation.
Yes,
Wonderful.
I think explanation is perfect. What about Mr. Chaminder?
Yes, thank you very much, Mr. Raman. I think you touch all the areas relevant for this new innovation in plastic multi-layer packaging. I have a small question. Now, for example, there are some Tetra packs in, I think most of the waste is not recyclable when it comes to Tetra packs. Can you use this?
If you
this
look
thing?
at the Tetra Pak composition,
Mhm.
paperboard, aluminum, and
Mhm.
plastic.
Yeah.
There's not much plastic in it. It's
Mhm.
more of paperboard and aluminum.
Mhm.
People salvage aluminum out of it by
Mhm.
dissolving it in caustic soda
Okay.
and making it into sodium aluminate and then get back to the metal. Um, in the process, you get a byproduct which is like a pulp, which is
Yes.
used for paper recycling.
Mhm.
Very little plastic.
Mhm.
I don't think they really bother to separate the plastic and use it.
Plastic, yeah. So, in my thoughts, I think you are doing it in India right now, and we have the same problem in Sri Lanka. This municipal waste available contaminated, sometimes contaminated that they can't use for another product. So, but this lumber and this pallet thing, I think it's a good opportunity for our industrialists to start because the raw
Yes,
material is available.
particularly the lot of packed items will have some food, leftover food, will have some fat like, butter, oil or whatever. And we have also used such material and to the extent possible, we have driven the odor out of it.
Mhm.
But there'll be a little bit of odor still there. We are trying ways and means to clean up, but even a perfume will not help. It doesn't last long.
Mhm.
The odor will come back.
Yeah.
After some. These are some of the problems. We are still not finding a 100% solution to it, but we are dealing with the problem.
Yeah, but I
But the
think it's an
point is,
overall solution for this plastic waste recycling multi-layer.
yes,
So, Mr. Raman, what we can do is, if there are any questions through these channels,
yeah, can
we
you
can.
raise the voice a bit? I mean, I'm not able to hear.
Okay. If there are any questions through these communication channels, we can direct it to you. So I can ask our IDB representative to send us the questions if there are any queries. So then I will forward it to you.
I'll be
So,
glad to answer those.
yes.
Certainly. I'll
Okay,
give the views. I don't think I claim to have a solution to every problem, but
Yeah.
okay, Mr. Chaminder. Then this is the end of our session. Thank you very much, sir, for giving such a descriptive explanation regarding this topic. Actually, the waste materials can be converted into valuable products, and new opportunities for entrepreneurs are being explored in Sri Lanka. So, thank you very much. I think this is the time to start up our recycling waste management sessions. That means by using the recycling procedures.
I
So,
have a suggestion at this stage. You see, we have already developed lumber sections out of it. I can sample your furniture makers so that they can have the feel of it. We can even guide them on how to fabricate. It's like wood. People have just treated like wood, and our carpenters have done a wonderful job building furniture out of it. Maybe that's a good way to start. We can commercially offer number parts, and agency like you can take the lead in, reaching it to uh, woodworkers or furniture makers and get the feel of it. Certain park benches kind of thing, we can give design inputs also, so that you make the public use and give the get the feel out of it. Therefore, the entrepreneur then he can jump into investment. He knows the market by that time. So for test marketing, I think we can help you. That's very important.
Yeah, it's a big pleasure for us, sir. I think in near future, we will try to conduct some awareness sessions regarding this topic also.
Okay.
So I would like to pay my gratitude to you, sir, for participating in this session, for giving us your valuable time. As well, the coordinating officer, just like a coordinating officer, Mr. Shaminder, thank you very much for your support to make this session success. Then all who, thank you very much for the all who were connected with us during this session. All the viewers, have a nice day.
Thank you so much. It was my pleasure too to get engaged with your presence, and look forward to more and more questions and interaction with the larger audience. Thank you so much.
Sure, sir.
Thank you. Have a nice day.